Hello everyone, welcome back to my channel EpistemiaX. Today we are going to discuss about random functions, where NumPy provides functions to generate arrays or random numbers from various distributions, which is excellent for sampling and simulation or other tasks also. Now before we start using random numbers in NumPy, we need to understand one important concept, generator. So what exactly is a generator? A generator is an object that creates random numbers. Now we will know how to create generator. First we will import NumPy as np. Now then np.random and store in a variable rng. Here default underscore rng creates a new generator, and RNG is now your random number machine, and you own it, you control it. So now you can generate random number like this. These are different random family functions. Now we will know what is seed in generator. If you want the same random numbers every time for experiments or testing purpose or debugging purpose, so you can set a seed. Imagine you are teaching a class and sharing code with your student. You want them to get the exact same random numbers as you, so they can reproduce your result. This is where the seeds contributes to the process. Now we will put seed value whatever you want. Now you can generate the same random output using the seed. Now we will explore four functions: random, integer, uniform and normal function. Now we are going to generate different types of random numbers using the latest NumPy method. Now let's start with the basic function, the absolute most basic type function, which is called random function. This function outputs a random floating point values within the range of 0 to 1. So let's start. First we have to turn on our random number machine. Now let's see what does this do. We have generated three random numbers between 0 and 1. These are the decimal, or we can say a floating point value. So main important point is here, range is always 0 inclusive to 1 exclusive. That means 0 can come but 1 will not come, and this function basically used in probability simulations and random sampling or many other cases in machine learning also. If we run this code again, we will get different output. Now let's see, we are getting different outputs again and again. Run the code. If you want the same output, then I start my machine with the seed number, then I will get the exact the same result at return. Let's take a variable rng1. Now seed, I am taking any number. I have to 23. Now let's see, if I run this code again, we will get the same output because we have put a seed number, then I will get the exact same output. Now let's see, run again. We are getting different outputs without seed and the same output with seed. If you want to generate 2D array using random function, rng.random, and we will provide a shape for 2D array. Now run the code. Now look this. If we run code again, we will get different output and different floating points. Now let's run again. we are getting different outputs. If we want to see it, now I am giving 43 number. Now let's see what will be the output. Run this code again. We are getting the same output after providing seed. In the same way, we are getting generate 3D array. Now we provide a shape 2, 3, 3. We need 2 layers, 3 row and 3 column. Now let's see what will happen. We will get an 3D array. If you want the same output, we will provide a seed number. Now I am putting 56 number. Now let's see what will happen. Run this code again. It will giving the same output. But decimal are not always helpful. What if you want to pick a random page in a book or roll a pair of dice? You need whole numbers. For that, we use integers function. You tell it where to start, where to stop, and how many numbers you want. Now let's see what is the syntax of integer function. Now see, this is a syntax of integer function. If you want to know each and every parameter of integers, just press shift and tab. Now you can see each and every parameter of integer function. By default, endpoint is false. And if you scroll down, each and every parameter is explained and with example also. Now let's take an example. If you roll a 6 side of die 5 times, now run the code. Now let's see. So this generate 5 integers between 1 and 7. So important concept is here. High value is exclusive. If you want to include, now look at this line of code. Let's understand. First question is here. What does this 10 means? 10 means generate random integers from 0 up to 10. But remember, 10 is not included. So the range will be 0 to 9, not including 10. So very important point is here, the high value is always exclusive. Now, what does the meaning of size? It means generate 6 random integers between 0 to 9. Now let's run the code. Now look, if you run it every time, numbers will change because it's random. What if I want to include the high value? It's very simple. Since NumPy includes a high value, you just increase it by 1. If you do not want to increase it by 1, just type 10 and endpoint is true. And I want to 8 numbers. Now let's see. 10 is included if endpoint is true. If endpoint is false, the 10 will not included. Now let's generate a 2D array. 2 by 4 matrix integers function. Number of integers. Size is 2 by 4. Now run the code. Now let's see these random integers numbers between 0 to 8. If you want to provide a low value, the output between 2 and 8. Now let's generate 1 by 4 array with 4. Look at this code and this one. Here we are asking the code to generate 4 different random numbers. And the first number 5 is our starting point, and the list are different ending values but not included in the output. So NumPy does something smart. It generates random integer numbers like this between 5 and 6, between 5 and 8, between 5 and 9, and between 5 and 11. So basically it pairs 5 with each value in the list. It creates one random number for each pair. Now let's run the code. Now look at this code. Here 11 is the fixed number and this list are different starting values. So NumPy generates integer random numbers between 5 and 11, 6 and 11, 8 and 11, and 9 and 11. Again, one number for each pair. Now let's run the code. Now let's move on the next function. We know random function is great for getting decimals value between 0 and 1. But what if you need a bigger range like a random decimal anywhere between 5 and 15? This is where our third function, which is called uniform function. The syntax of the uniform distribution is similar to the integers function, but it has no endpoints included. Now let's see. Now let's take an example. I need 4 random decimal number between 5 and 15. Let's run the code. Now look this line of code. Uniform function generate decimal numbers between 5 and 15. And the important point is here 5 is included and 15 is excluded. It is the same as the integer functions, but it has no endpoint included. If I want 2D array, now this is important point is here 2 by 4. That means it creates a 2 rows and 4 columns array. So instead of getting just one number, we are getting a matrix of random numbers. That means it generates random decimal numbers between 5 and 15 and arrange them in a 2 by 4 matrix. Now let's run the code. Now let's move on. Next function, normal distribution. This is one of the most important function in data science and engineering. It generates data that follows a Gaussian normal distribution, which is also known as the bell curve. Imagine if you measure the height of 100 random people. They won't be evenly spread out. Most people will be clustered right around the average, with a few really short people and a few really tall people. This creates a famous bell curve, or we can say the normal distribution. To generate this realistic data, we don't give it a start and stop value. Now let's see the syntax of normal distribution function. This is the syntax of normal distribution function. Now break down each parameter of normal function. The first parameter is LOC. LOC is the center or mean of the distribution. It is where most of your data will cluster. By default, the value of LOC is 0. Now the second parameter of normal distribution is scale. That means the spread or standard deviation. This controls how spread out your data is. A smaller scale means data clusters tightly around the mean, and larger scale data is more spread out, and by default the value of scale is 1. And the third parameter is size. That means this determines the shape and amount of random number you get. It can be a single number or it can be a tuple for multi-dimensional number. By default it returns a single value. Now let's generate normal distribution data. Here 5 is mean, 1 is standard deviation, and 10 is how many random numbers you get. This creates number centered around 5. Now let's run the code. When you look at your output, most of the numbers will be hanging out around 5. Now let's plot normal graph. For this, if you want to get a smooth bell curve shape, we need to some changes in data. First, I have to import matplotlib library. Now look at the shape. It forms a bell curve. This means most values are near the mean and fewer values at extremes. So today in this video, we learned how to generate random numbers using NumPy. First, we create a generator object using the modern method default underscore RNG. Then we explore different random functions like integer, random functions, and uniform and normal distribution function. These functions are very useful in data science, simulations, and statistical analysis. In the next video, we will continue to explore more NumPy functions. If you found this video helpful, do not forget to like, share and subscribe to the channel. Thanks for watching. I'll see you in the next video.